All right. Oh. All right. Thank you all for joining today. And this is our second day in the WaterSoftHack training week. And today, myself and Carlos will be your trainers. And we are going to cover a suite of different applications, covering from data integration to acquisition, processing, transformation, as well as analysis and visualization. So we're going to introduce a software suite called Hydro Suite, which is a suite of libraries. So maybe I can start by introducing myself again. So my name is Ibrahim Demir. I'm an associate professor at the University of Iowa and the director of the Hydroinformatics Lab. And the Carlos Erazo maybe can introduce himself in a couple of minutes, but he's a PhD student working in our group and the main developer and architect of these some of these libraries. And HydroSuite is actually a collection of 20 plus libraries available for hydrological data analysis, integration, and visualization. It includes libraries from hydrological analysis to machine learning to statistical analysis, as well as visualization and data acquisition components. We have some high-end libraries for advanced hydrological data transfers using new technologies on the web systems, as well as some high-end computational libraries for parallel computing using GPU, CPU, and others. We have geospatial analysis libraries, as well as model integration libraries as well. There's many more libraries that you'll be able to explore under the Hydro Suite. We are going to cover 3 core libraries called HydroLang and HydroRTC and HydroCompute in the next couple of days. And I'll start with some high-level information about where we are in terms of computing and hydrological analysis. So you can see that there are so many programming libraries and programming languages available and used currently for hydrological analysis all around the world. And JavaScript, since it's supporting the interactive elements on web systems, is one of the most popular languages in the world, with many programmers learning this language for common web technology tasks, from websites to social media platforms for entertainment systems, educational systems, as well as scientific applications. And right before HTML and Python, JavaScript is very popular in terms of the web-based technology development, but also in terms of computational power as well. By using some native languages, you can get to the same speed of C++ or others, but also JavaScript as a native language itself is very powerful, using some latest computational engines for creating large-scale data and visualization applications and analysis applications. And in terms of the speed, you can say that the JavaScript as the speed is almost like roughly half of the speed of C++ as a native language, but it's probably 10 times easier to code. But also with some native integrations with assembly language, you can easily create same speed applications in JavaScript as well, using C++ or other languages. But just the native implementation of JavaScript is also very fast, but you can easily switch to parallel computing with multiple CPUs and GPU computing and gain multiple times speed up on the web technologies. And web is definitely growing significantly over the last couple of decades. We have now libraries that can access the graphical processing units for using full power of GPUs for AI applications, for visualization applications and analysis applications. The WebAssembly standards and libraries allows you to run desktop level languages directly within the web. So you can compile your C code or Python code and Fortran or other languages directly to work within the web as well. And the WebXR and WebVR allows you to connect with native visualization devices like virtual reality devices, augmented reality devices, and use them within your web application. Similarly, Web Workers and WebCL allows you to run parallel computing tasks and accelerate your analysis and visualization. And finally, WebSQL and Web Storage libraries allows you to load gigabytes of data based on your local storage. You can load, for example, 100 gigabyte flood map library or elevation library and analyze and carry out some computations directly within web applications. And you can also store them for future analysis, so you don't need to download again. It can be consistent or persistent storage, as well as run offline without a web server or internet connection. And when we come back to Hydro Suite, as you can see, under like 4 core areas, we have over 20 libraries. These are the most common libraries that we currently have, including the data processing, data integration, data standards like ontologies, data specifications, and data models. On the computational side, we have several programming libraries that makes it easy for hydrology and water resources professionals to run and analyze and run a code or write a program to carry out some hydrological analysis. On the communication side, we have several libraries for both virtual reality communication, AI-based communication, as well as some analysis libraries, 3D geospatial libraries. On the community portals, we have several web portals that allows you to work with some machine learning models, web-based libraries, as well as modeling and visualization components that can be shared by the community. So HydroSuite is designed by the University of Iowa Hydroinformatics Lab, which is available on HydroSuite GitHub repository, but most of these projects are independently published and shared with the world as an open source and free library. You'll be able to access those libraries, and you'll be able to use them potentially with the core libraries that we are going to provide training this week. So in the center of the HydroSuite, a community-oriented collection of open source libraries and repositories. And our goal here is to bring the web technologies and domain-specific knowledge together to give you powerful software libraries for the hydrological community. This could support either research, educational activities, as well as professionals and operational activities by the urban planners, government institutions, and other entities. The goal here is to create a community of researchers and users and developers working together to bring their own expertise to hydrological domain. So the first library we are going to provide training this week is HydroLang. It's a hydrological programming framework. It's an open source library for hydrological and environmental analysis, entirely on the client side. You don't need to install anything. You can just download the library, start programming. You don't need a special editor. You don't need a special server. You don't need to install Python or some other backend systems. You can just start coding and use the examples. We also have a web-based sandbox for programming. So you don't need to even open a code. You can just go to a website, start testing your code, writing your code, and learn about HydroLang directly within the training program, which has some ready-to-use examples and coding sandbox for you to change and run a code instantly and see the results. It's a scalable and applicable system. We work with many researchers and students designing different components and modules and functions for HydroLang. We have several different versions of HydroLang that works within the web components as well. It's a community-oriented library where we want community to contribute with new functions, new modules. I think one of the maybe critical step for us is to involve you both for using the library as a user, but also as a developer. If any of you is interested to work on designing a new function, new module, please reach out to Carlos and work with him maybe throughout the next 2 weeks and create some new functions, and you will get some recognition and be part of the developer ecosystem for HydroLang. HydroLang markup language is the second generation of the HydroLang, which is actually creating a web component library around the HydroLang, which allows you to write just a basic HTML-like code to create hydrological analysis. As you can see from here, rather than writing a Python or C code or even a JavaScript code, you can just write a simple HTML commands, starting with HydroLang and connecting the analyze module providing some attributes and data sets, and you can run an analysis by just 5 lines of tags. These are all HTML-like tags and components. So you don't need to even write a code. You just write these tags, defining what you want to do, and it will be converted to JavaScript in the background, and you can run this. And these are also open source libraries you can access from the GitHub and access the documentation and training on these libraries as well. So BMI.js, the BMI is actually a critical component for model-to-model interaction. So the basic modeling interface is a standard provided by several universities working together to create this interface that allows models to talk to each other. There are several different specifications are created for BMI, including C, C++, Fortran, Java, and Python. And recently, our group created the BMI JavaScript, which allows you to talk to other BMI-enabled libraries from JavaScript, as well as connecting with different data sets and models together. So you can access the BMI JavaScript from our repository as well. And Carlos will show some examples in the coming days about how to couple models together using BMI JavaScript. Another critical module is Hydro Compute. This is a very powerful computational engine that connects to multi-CPU cores as well as GPU for parallel computing in hydrology. And it allows you to load large-scale data, run large-scale analysis on the browser within the client-side environment. Rather than utilizing a server-side computing environment, you can use Hydro Compute to run large-scale analysis on the web. With a couple of lines of code, you can parallelize your task and processing and access the power of GPU or power of the multi-CPU systems. So without using an HPC environment, you'll be able to use your own computer to access all the cores of your CPU. If you have a 4-core, 8-core CPU, you'll be able to potentially accelerate your project runtime 8 times faster. And the final library we want to probably introduce is the Hydro RTC. This is a real-time communication library. This is actually a new standard for a decade that large-scale data streaming is heavily utilized, especially systems like Netflix and many others are using this technology to stream large-scale data sets, gigabytes of data, 4K videos, or some other data sets to users. And we are using the same technology for environmental science, for hydrology. The idea is to stream, for example, gigabytes of flood inundation maps or elevation data or raster files or satellite imagery directly to the users fast enough, but at the same time dynamically allowing them to access and potentially analyze and consume as they receive this data set. This is the Hydro RTC, a high-end communication data transfer library, allows you to access data directly from a server as well as access from another user. So because it's a decentralized approach, allows you to access the data sets that you want to download from USGS, NOAA, or other agencies directly from another user that already has the same data sets. So this technology can allow you to talk to peer-to-peer communication systems and allow you to access these data sets on the fly. And as a high-level vision, we are actually at the stage of creating a visual computing environment. We are further simplifying the HydroLang and HydroLang markup language to a visual language where you will have building blocks to create your hydrological analysis and programming. This visual programming will be mostly using like building blocks similar to Lego or puzzles, where you put together pieces, where each piece will be carrying out a specific task, specific analysis, and you can build together on a visual environment. Rather than writing a code, rather than writing a markup, you'll be able to just put together building blocks for a programming or visualization or data analysis or data integration project in matter of minutes. And further improvements are actually ongoing for this project to connect to conversational AI where you can get help from AI in terms of your programming or setup, but also in the long run, maybe the last phase of the project will be an AI-based automated computing where you'll be able to just talk and explain your needs in terms of data and modeling analysis, and the system automatically put together the visual computing environment for you. So this is just a long-term vision and project. We are already in the 60-70% of the components are developed, and we'll be able to share with you today and the coming days. But we are going to a direction where it will be almost no code programming environments, both visual and AI supported. So you'll be able to create hydrological code analysis on the fly by just talking and providing some instructions to the AI, and you'll put together something very, very strong. So this is the progression from AI-assisted programming through chatbots and code helpers and code sandbox to a visual programming stage where we have a plug-and-play modular and building blocks. We are currently working on this, and hopefully we'll have something early fall. And then finally, late fall or maybe in the spring, we'll have an AI-based automated programming environment, a visual programming editor, voice-enabled system, working with AI research agents, and working for you to create research components. So I'm going to stop here and give the floor to Carlos. And Carlos, can you maybe share your screen and go from there, and you can have the full control over your slides. So Carlos will start introducing you the major components, and then also start talking about the specific training modules today, and he will continue tomorrow and Thursday covering the major components. I'll be on Zoom and also on the Discord. Please reach out to us and ask any questions throughout the day. And I suggest you to start thinking about your project idea and components and have a plan. And please reach out to us on the project channel on Discord for any questions. All right, thank you.
All right. Thank you, Professor Ibrahim, for the high-level vision of the Hydro Suite. And thank you all for attending today. I know that we're all very excited about learning a little bit more about the data analytics part. And we're going to be covering quite some content today. However, I want to make sure that if you have any questions, if you are, some doubts, please let us know in the Q&A chat, and we'll be sure to just address those as we go. So again, thank you. We are at the University of Iowa. I am a PhD candidate. I have been main developer in several of the softwares that have been shared today in the Hydro Suite. However, this is a collection of different approaches that have been taken to solve multiple problems within hydrology and environmental sciences. And so there is software for different kind of scopes. And I would really encourage you that you take a minute to take a look at all the software that we have available over there. Hopefully, with the training that we're going to be giving this week, you're going to be able to find the value and perhaps include it into your capstone projects. Well, let me just get started. I'm going to be talking a lot about some of the background about data retrieval, data APIs. So if you feel that it's a little bit long about that, well, you're probably right. But I want to give a good, coverage of all these different things prior to start the coding itself. However, I want to make it comprehensive enough so that you have all the knowledge available to know where the data sources are coming from, different data formats also depending on your domain and what you want to achieve. So let me just get started right now. I'm going to move this screen right here with the objectives of today. First of all, we're trying to showcase, understanding different data types that are commonly used in hydrology. I know that there's many people from across the United States and abroad as well that are working in different kind of problems. So yeah, excited to hear about that a little bit too from your end. We're going to be learning about the multiple data collections and methods available. So not only, okay, there's different types of problem that we have. How is this problem translated to data? How is this data then collected? And what are the different methodologies used for this? Recognizing what are the most data common data formats, because there's different landscape depending on what we need. And so these formats will, of course, have their own hindering issues or perhaps their difficulties. We'll try to cover them throughout this week. Today, the main purpose is help you understand and see what's out there, what's available, not only from the stuff that is available within the libraries that we showcase, but also from public entities, from works that other folks are doing outside. So the tools and libraries are going to be using, again, it's going to be mainly Hydrolang for the day. And also I encourage, probably not going to be using, I have a little bit of an example for using for Python. I know that a lot of people are more comfortable with Python. So I'm just going to show you some data retrieval process for the same, the way you do with the JavaScript version, the way you do with the Python version. You don't have to install anything right now. This is going to be a showcase. If in any case, we would want to move towards doing something in a particular language, we will let you know, and we're going to share those over there. And the tools for development, right now, you don't really need anything. We're going to be working using the online sandbox, the code sandbox environment. There's two different ones that I'm going to show. However, for the capstone project, perhaps you would want to work locally. And so I would encourage you to perhaps look into VS Code, depending on your project as well. If you want to install some dependency over there, we can help out with that. And if there's any examples that we're going to be sharing, it's going to be doing with Google Colab through the Python environment. So I'm going to be showing the links now for the development, the Hydrolang tutorial, HydroRTC, HydroCompute. They all have the same URL in the beginning. So the only thing that's changing is the title of the library. All of them are comprehensive enough so that you can take a look and see what you want. But I also wanted to share these other resources so that you have them available. So I'm going to stop here so that you can take a look. If you go into the, see, I think this guy should, yeah, there you go. So if I go into Google Earth Engine, again, I'm probably going to be showing this tomorrow and on Thursday too. A different platform for running with imagery from satellite data or others. And the Google Colab, I don't know if any of you guys have ever used Colab before, but it's very intuitive and fairly simple to use. But I'm going to assume, that we are new with this whole development, and that's actually a little bit better, so that if you feel that we need to pick up the pace, please let me know. I have absolutely no problem with that. Or if you have any questions, please let me know too. Now, something that I do want to showcase is these examples of the capstone projects. So I know that the fellows are required to do these capstone projects. So please take a look at these ideas that we have put together in here. These are just examples. If you have your own data sets, if you have your own ideas about what you want to do and what you want to showcase, you can put it again in the Discord. You can put it in the chat as well. And some of the ideas are, for instance, streamflow forecasting from real-time data, water quality analysis tools through connecting different sources, climate change data analysis, watershed management, drought monitoring, and the examples are quite broad. The idea is you connect through a data resource, you then clean that data, analyze the data, and you put in a visualization whether that is a map, whether that is a chart, or it's a real feed example. And so you are having the broad landscape of what you want to see within your application, right? So I'm going to show you a quick example. This is an example that is, it was developed for some stations in here in Iowa for stream flow forecasting. And so this one is a web application. All of this is just HTML, so it's just write up. And it doesn't have, it's very simple. It's fairly intuitive as well. What's doing is it connects to a USGS data source. I'm going to show you how to do that afterwards. And then we're in Iowa City. So of course I'm querying Iowa City, and this was developed for Iowa. So we have some Iowa stations in here if you want to go to different county. And the idea is, well, I have my visualization, I have my data feed. This data is afterwards, I can just toggle along and select it. And I want to download some of the stations that are available, retrieve stations. And after some time, some of them are going to disappear. And then I'm going to get a very simple statistical analysis of it so I can start moving forward, right? So getting some of the stations, what do they mean, start end of the recording time, mean standard deviation, skewness, kurtosis, some basic statistics, and afterwards, per resource, again, this was put fairly quick. So it's a little bit Yankee at some point in some positions, but what we're trying to do is showcase how through a simple statistical analysis, you can just put this together in the browser. So this is not connected to any server. This is just rendering directly in my browser through the libraries that we're going to showcase today. But this is one example. Again, you're not meant to be doing something exactly like this. It's just an example of what some of the things that you might be able to do with the knowledge that you're going to get today. And some ideas. So I'm really curious to see if there's any ideas. So if you would like to put that in the chat, or if you want to put them in Discord, please do so. Even if you don't have any ideas, also please say, yeah, I have no idea what I'm going to do, or I have some data sets, but I want to explore a little bit more, and let us know, and we can take it from over there. Okay, I'm going to answer a question quick. Galina says, put the link in the chat. What link are you referring to, Galina? Let me. If you could write up again. Oh, the example part. Yes, of course. Let me just do that here. I opened everything up. Yes, definitely. This is a good start for the analysis. So this is just going to be a quick example. I'm going to copy paste this, and I'll put it in the chat for everyone. Also, I think we can share these slides afterwards, so you guys have more resources. I think we didn't share them before. Apologies for that. But we will afterwards. Good. Okay, so let's get started then with the background of what I wanted to talk about. Introduction to data retrieval, right? So what is data retrieval? Well, it is how am I going to do an analysis? How am I going to create something and showcase to stakeholders, or showcase to my PI, or put it in my nice paper that I'm writing? How am I actually doing that? More than anything, where am I getting that data from? How is that data collected? Is it reliable or not? And those are the kind of questions that I want to raise up today. How important it is to have the correct data for any type of modeling. So you're doing flood forecasting, you're doing drought monitoring, you're doing I don't know, any climate change related endeavor, you're doing some hydrochemistry on river networks. Right now, Iowa, for instance, with we have had a lot of water coming in. And a lot of the nitrogen that has been fixated on the soil is now running. So the nitrogen levels have been spiked up, and you can take that look into the sensor networks that are available. So that's very interesting because you can say, okay, well, this is a problem that I want to take a look at. How am I going to get that data from? And we can have then a positive or negative impact based on the decision making that we have if we have incorrect information. So you are using data that is not reliable, using data that is faulty, using data that probably might be biased towards something. So that puts you in a position of, it doesn't matter if you start, if you have a very correct analytical tools for afterwards, what data you're using for that. That's a big part of the input. And so what is the data retrieval process? Well, we all probably are familiar with this: collection, processing, parsing, and then using this for the connection of APIs. So what is collection? Data collection is the process of you gather and collect measurable information on variables of interest. So as I was mentioning, there's multiple sensors deployed everywhere. We have sensors for precipitation, for evapotranspiration, for streamflow forecasting. We have for different kind of variables. Many times these sensors provide the multiple variables across time and space for a single location. So there are sensors that just the sensor that's right here outside of the lab is providing streamflow forecasting. There's some sensors that are providing both evapotranspiration and some other variables too. So that's very interesting. Now it involves, of course, the use of different techniques for placing this sensor technology somewhere. And how am I going to get the data also is through surveys, experimentation, observations, data gathering through sensors, web scraping. There are many different ways in which the data collection process goes from A to B. But it is indeed the most crucial step for getting actionable insights moving forward. So what is the data processing part? Data processing, that's a very broad statement, but basically is transformation, analysis, and generating insightful information from data. So the idea of the data analytics part is you get your information, then you process it a little bit, then you need to remove a lot of the uncertainty through corrections, through some statistical analysis, and afterwards you're going to get the real valuable information from over there. And what are the stages for the data processing? You have data cleaning, transformation, integration, aggregation, etc., etc. We're going to go a little bit more into these two first steps tomorrow. The processing is done through filtering, sorting, normalizing, summarizing data too. And the main purpose of transforming information into a meaningful, usable format. So meaningful, usable format is largely based on what the end use case is all about. So am I just going to show you some simple streamflow forecasting, like the example that I was showing before with the dashboard? Well, you can do that. Am I going to create more predicting knowledge towards showing, I don't know, a forecasting or something similar to this? Then probably I need to do some more processing towards that. So, of course, the data processing part entails a lot of questions and a lot of things that you need to consider. Now, data parsing. Parsing is the process of analyzing data and converting it into usable formats. Usable formats, again, depends on the end use case that we're trying to develop. Many of us work with, we work with web applications. We work with specific formats web applications, but of course, you folks probably work with GIS systems. probably use R, Python, C, C++, any other programming languages or frameworks or programs that you need, HMS, HECRAS, all of this that have particular formats, that have particular different ways of interfacing with data. And so interpreting and organizing your information in a format that is usable for you is a critical step as well. And this is done through tokenization, syntax analysis, semantic analysis as techniques. You're going to see in, I think it's second year, afterwards, the process of machine learning and how the machine learning is actually being done. And this whole parsing and mangling of information is a crucial step, of course. The data parsing also includes data extraction, transformation, integration, and a way of communicate this information in a usable. Now, we talked about the data collection process, parsing, transformation, but now how am I going to, I have my data, I have this information, how can I democratize this? How can I show with this data outside to the world? This is through, mostly through APIs nowadays. An API is an application programming interface, which allows us to put this information somewhere on the web. Somewhere that means it doesn't have to be in your particular location. There's servers outside. And the idea is you connect with sources from across the world for different formats and scopes, and it's accessible anywhere, everywhere, wherever there is internet. And the good thing about this is now we have some powerful computers in our pockets. And we're able to see this amazing and interesting information right there in our phone. And this is done through APIs. It is reliable based on data source and the provider. So the reliability part comes in hand. You have to be very careful where you're getting your data from. And it is the most common way of using data. So I want to ask you guys, what are different data types that you commonly use in your field? So I'd like to open the floor if anyone wants to share, if anyone wants to put in the chat, anything that you think it's interesting for you. No one? I can move forward. That's not a problem. Just take in mind what is data format that you want to use and consider in your particular research, in your particular domain, and see what that data, where are you getting this information from, and is it reliable or not? Okay, I got some responses, CSV, text, some Excel, stat, okay, netcdfs. Chat is disabled. Oh no. Let me see if I can enable it here. Thank you for saying that, by the way. I didn't know that it was disabled. Let's see. I'm gonna stop my share quickly. Well, I do not know how to enable the chat, but you can still share it in here in the question and answer, so that's great. I'll share my screen once again. There you go. Slideshow. Okay, I'll go back and say CSV format, Excel files, remote sensing, grid netcdf, and CSV. Let's see, HDF5. So we're going to be covering some of this today and in the next day as well. TIFF, streamful water quality. Okay, interesting. CSV, netcdf. Raster shape files, HDF5. So there's a lot of folks then that are using gridded files for doing their data processing. That's really interesting. I'm happy to hear that. Okay, perfect. Something else that you might want to put in there is what are the tools that are you using for doing your data processing? So if you want to share that while we move along, and then afterwards I'm going to stop to read you. So, okay. Go back. Part two. So data types in hydraulic environmental sciences. Some of you guys were already alluded towards. What are those data types? And I'm just going to mention some. These are, very general ideas of what it looks like. What we have are time series data, spatial information, remote sensing, water quality, among others. So, of course, when I'm saying time series data, time series is everything, right? You have stock exchange, you have different kind of things that are better seen through time. And what that is an observation of running variables, something that you're observing continuously throughout time. And examples that we have in the hydrological domain are water levels, precipitation records, concentration of different kind of pollutants or nutrients such as nitrogen or phosphorus, particular concentration. So if there's anyone that is working with sediment transport, that's also something that you can analyze through time series. Point data, it is time series is point data. That means that for a particular location, for a particular time, you get information. And that information can be, of course, very similar across your spatial domain. However, if you want to understand the particular what's happening in a particular place, point data is right there. Spatial data, of course, GIS input. So for the folks who do not know GIS, Geographical Information System, outputs from imagery or analysis. So you have satellite data that is crossing throughout the world. There are different products out there, and these products then are put out for our analysis. And there are layers that contain information from time snapshots. So it is on itself a time series data too. And these layers include remote sensing, satellite imagery, radar data, and so on and so forth. Water quality, again, just as the example that I was saying with Iowa, chemical concentrations, pollutant levels, point source locations. So if you want to know what's happening in a particular place, examples of this are eutrophication studies, environmental impact assessments that are done across states. Understand how a pollutant concentration is moving from one point to another, and it is location specific, and so modeling or moving forward, this data might not be the most reliable. However, that is also based on the location and what kind of data observations you're making, right? Example use cases that I have in time series: streamflow monitoring, rainfall patterns, groundwater levels for spatial information, watershed delineations. That's something that I remember from my courses, and we have actually a library that does watershed delineation, floodplain mappings, land use coverage analysis. From the remote sensing part, water body satellite imagery, snow cover analysis, soil moisture estimations, and the list goes on. And as I was mentioning, water quality, pollution source identification, drinking water safety, and so on. Data collection methods. Okay, so I'm going to stop just to see the chat real quick. Let's see. So some people are using Python, ArcGIS, okay, MATLAB, R, GIS, Python and R, ArcGIS, Excel, Notepad++, Notepad++. Oh, I'm glad that someone else is also using Notepad++. NV, what is NV? I've never heard what NV is. Oh, interesting. RStudio, okay, QG, some Python, Bash. Okay, great, Bash. ArcGIS, Python, Google Earth, Office, remote sensing, DSS. Amazing. This is so interesting, all the tools that everyone's using. And hopefully with the JavaScript part, I'm just adding up to your toolbox. Okay, good. So data collection methods that we have are ground-based best sensors, satellite observations, manual sampling. So in terms of ground-based observations, we have multiple different data types. For instance, rain gauges, stream gauges, soil moisture sensors, groundwater sensors as well. In the with respect to data collection, real to near real-time data collection. And I'm sure that a lot of you have had to struggle with this. You know, we always want the finest resolution for both spatial, you know, across space and across time as well. So if you have those 5 minutes time series from StreamFlow for you using it in your model, that's going to be amazing. Or if you have 15-meter DEM, that 15-meter, that's maybe a little bit of course. Maybe I've seen 5-meter DEMs and 2 meters DEM. That's so heavy. And afterwards you have to go into an HPC. So what I'm saying is having all this real-time information means what is the resolution that you require for your data, and how is the resolution really feeding into your data? Because sometimes you don't, you can do a lot with coarser data sets, right? And that's something that you have to consider also for your capstone. That's what is it that I have this data set, it's very heavy. Do I really need to use all of it? Do I really need to get those 5 meters or 2 meters, or can I just generalize it a little bit further? So that's something interesting to understand. Accuracy and calibration. Who deployed this data? What is calibration? What is the calibration process? What is the source of this process? Specifically, if you're into forecasting data, how am I pushing forward towards the calibration process? And so this means for ground-based sensors, challenges is maintenance, susceptibility, spatial coverage. There's only so much money that you can use for spatial coverage, so you have to be really smart on where you put your sensors. Satellite observation, you know, we have a wide spatial coverage for surface water bodies, snow coverage, soil moisture, vegetation. The technologies that are being used for this: optical imaging, radar, LiDAR at different temporal resolutions, as I was mentioning before. Data integration, coupling ground-based and radar-based data for accuracy and assessment is a primordial task whenever you're dealing with satellite data. There is very talented folks in here in Iowa who are doing large-scale Landsat and other satellite observation information. And, you know, getting the insights of the challenges that they have is, you know, the basic things: cloud cover interfaces, complex data processing, interpretation. Again, many of the products for satellite observations are paid, and sometimes you don't have licenses, or sometimes you need to go through other resources. So there's still something there for that. Manual sampling. These are more for the folks who are doing either groundwater or nutrient observations. So accuracy and specificity is something very important to consider for variables such as pH, turbidity, or nutrient concentrations of contaminants. The flexibility, a pollutant source identification or localized assessment. So how general can you go about this? Hands-on verification and observation and all the processes that have been done for moving forward with the data collection process. And what is the challenge? Well, you need people. You need labor. Is quite labor intensive, it's time consuming. And at the same time, just as with the ground-based sensors, there's limited coverage. Okay, so I'm going to go now into data formats and conversions. And this is where we're going to start going into the nitpicks of today's discussion. So one of the examples of data formats and access, at least through the web, and I know that you guys are working also with Python, working with R. These are just formats that we were mentioning before: JSON, XML, CSV, GeoJSON, shapefiles. All of these are easy to use and compatible almost everywhere. So probably your computer has a parser for it. And it's high performance throughout the whole application or the whole analysis stage, right? JSON is fairly easy to manage, just as any other ones that are used over there. However, this can be very extensive, and though are easy to interpret, there's still limitations to them. And this is where the main specific ones are coming in. So you have netcdf, RIP files, oh, there's a repetition there of shape files, HDF5, any other kind of gridded format, which the main features of them are there are multiple variables and temporal resolutions that are packed. So that means that you want to extract something from a time series, you can just get it from a single file. Now, they're not easy to unpack. They're sometimes very difficult to understand even. The processes, many of them are, of course, just a step forward into from being binary into being what they are. So that means there's still some labor that you need to do from your end for going forward with it. So I'm going to explain more about JSON and GeoJSON, and these are the main web application, the main web formats that you're going to be seeing across web applications. JSON stands for JavaScript Object Notation. It is a standard that has been established by the World Wide Web Consortium. It is used in many different ways in web applications. Whenever you are downloading something and you say, hey, I want to save this in my as my cookies, that cookie itself is also a JSON object. It is being used in the scientific domain as a steering file. It is data format for streaming data too. So whenever you get a response from an API, you're probably going to get a JSON object, or a REST API should have a JSON object available. It is the main format, again, for data exchange on the web because it's very easy and scalable. And it can be parsed throughout different environments. It can be parsed in Python, in R, and C, and C++, in JavaScript, and Ruby, anything that you guys might want to explore. Why? It's because of its simplicity. It's just bracket notation. You have the quotes. And the example that I'm giving on the right, sorry, is GeoJSON. So GeoJSON stands for a particular geographical format that is now being used, not now, but it's being used for quite some time for mapping. For instance, this is a point for Iowa City, and what you have is the type, a feature collection. So that's how it's called. What type of feature do I have? It's a geometry. What kind of geometry do I have? It's a point. What are the coordinates for that point? Is the coordinate system that is in here, and then afterwards for the properties, the name Iowa City, for instance. And everything is just how am I going to collectively grab those things together and put them on a single place. XML stands for Extensible Markup Language. It's very, very old, which makes it very durable, and a lot of people use it, right? So if you're going to afterwards, when we go through the different data sources, you're going to be able to see most of them have XML formats. So XML is structured and customizable. It supports nested data structures through hierarchical formats. And what is really interesting about it is that it's used through for different kind of things also in web applications. So for configuration files, document storage, and there are standards that have been applied with XML, for example, WaterML, which I think I read the other day is going to be superseded by OGC. So the OGC, I don't remember the standard name of it now, but it's supposed to be superseded for that. And we have some version of this XML because of how easy it is to create for HydroML, which was mentioned before. And the example that I have in here is a little note, right? To all of you guys that from Iowa, a reminder that we have a training with this team. So as you can see, it's this notation right here that afterwards is being closed. For each of the indentations in here is just a declaration of what it is that I'm trying to do. And it's very scalable for that. Shapefile and GIS formats. So these are representations of spatial information. through different kind of ways, particularly vectorized formats. Some of the formats that I'm mentioning here are raster shapefiles, databases, KML, GeoJSON, TIFF, GeoTIFF, GML, and there is a broad combination of these. Depending on what you're working on, you're going to be focusing on probably multiple of them because many times it's easier to manage them in different ways. It is a combination. They represent a combination of spatial features with attribute data. For a particular location, you're going to get information for that particular location, depending on the features, right? And the gridded formats that we were talking before. So NetCDF, RIP, HDF5. I know there's many others. Those are the ones I wanted to cover today. We have storing large amount of data through an efficient stack of spatial Templar layers. So in here for the figure of HDF5, you keep metadata with the data. You have a large throughput of information that can be put in a single file. It is fast input and output operations, cross-platform, easy shareable, and there's heterogeneity throughout, and that makes it very scalable. Just as much the NetCDF as well, different layers that you can access, and depending on quite frankly, depending on the programming language that you're using for analysis, sometimes it's easier to interface with this data set. Sometimes it's a little bit trickier. I know that for JavaScript, it's a little bit trickier to still parse them. I'm going to show you some examples of how this is done. However, I know that a lot of people use R for parsing these files, or Python that has really good libraries for that. They are widely supported across the scientific domain, so it's not just for hydrology. This goes for chemistry, this goes for physics, this goes for everything else, because of their different stacks that are being put together. We're able to get metadata that is rich, and you can get proper interpretation. Again, the main roadblock with this is the starting point, right? So you don't know how to handle them properly. And so it seems like a big stone or a big wall in front of you. Now, conversions. What am I meaning with conversions? Extracting features and information prior to making an analysis. Why? Because what my end use is for this data set? Or what am I trying to get from the data set, right? So if I have my raw data, what is the usable format that I need to get the insights that I expect to get, or what are the different formats that I can manipulate this information from. So these are questions that you have to make from where you're considering, of course, not only your research for a capstone and everything else. How can I showcase my data? Maps, charts, other visual formats. And for that case, what is the engine that I'm utilizing for showcasing the data? What is the workflow that I'm having? And what are the different kind of conversions that I need to do? Okay, so I'm going to go into the chat. I know that there is some questions over there. Someone says more like HTML. Yes, indeed. HTML is part of how you write the XML format. So there's a lot of web development that's been done for grabbing this idea and created this customizable events. This customizable software that you can just use as a plug and play. It's very, very good to do. Okay, so public APIs and data resources. Okay. So going again into what is an API. An API is an application programming interface. So an application programming interface means that you have a big program, you want people to interface it, you have some valuable things that you can do with that program, but you don't want to expose all of it, or you want to make it easier to use. So that's what the API does. It facilitates an automated way of interfacing with that, and particularly for data sources, the retrieval and integration of information from public sources. And it promotes easy access through the use of web technologies. Example of this are the public agencies such as USGS, NOAA, NASA, the EPA, Quasi HydroShare. I'm sure that you guys use a lot of them too. There's different variables that you can obtain from for different locations, and each of the agencies that I'm mentioning have different endpoints. So an endpoint is how you reach out to this application programming interface for narrowing down specifics, right? So what are the benefits of a program of an API specifically for data resources? Is real-time updates and data sharing. You're able to both get data into a quick example. A good example is in your phone. You get data in your phone, and afterwards you're able to see disaster declarations, for instance, or you have an alert that's being done through an API that is being called. Afterwards, the data is manipulated and showed to you on your screen. Also for data sharing, say that you have data that you want to put together. There are many different ways in which you can create an API, data API, so you can share that information across the internet or for different people. So this idea of an API, which is what we're going to be using today, by the way, with HydroLang, is we're going to be using a HydroLang API to access the API, the RESTful API of different data sources. So we're able to obtain comprehensive data sets, and there's easy integration into these applications. Now, all of us use different programming languages, have used different programming languages, or maybe you don't have experience with programming languages, but I just wanted to mention this particular way of getting data. There's libraries out there for both, for all programming languages that are made so that you're able to make these calls for information in the way that it's supposed to be done. So an API has a RESTful, a data API has a way of being interfaced. This is probably in the documentation of the resource. And these tools that I'm sharing in here have all those scaffolding in place so that you can interface. So for them, I'm mentioning some from Python, Postman, Perl, Swagger, some from JavaScript, the jQuery, and the list goes on. So particularly talking about, of course, web APIs, I'm going to go into two different protocols that are being used for getting data. So the first one is representational state transfer, or REST API, is a standard for creating calls through the web using HTTP. Okay, so that's a mouthful. It's hypertext transfer protocol. This is a protocol that's been put in place for sharing information through the internet a very long time ago. It has methods. It has different particular methods, and we're going to be exploring a little bit of those methods afterwards. Get, post, put, and delete. These are ways. It depends on the data sets many times. It depends on the institution, what kind of API they want to set up. So we're going to be making calls to these APIs based on this. And typically it's in JSON or XML formats, so the formats that we were talking before, but you can also get data in binary format and then you just transform it. For instance, I've seen people getting binary data for shapefiles or for some other formats. And then there is a particular, you know that is, to give you an example, an XCDF file, and then you just transform it into that from the binary. What is the main advantages of this is scalability, its simplicity, and it is stateless. Statelessness means you can deploy this almost everywhere, and the browser is going to understand what you're trying to do. Another version of an API is a SOAP, or Simple Object Access Protocol. The data sets that are being obtained through SOAP protocol are XML. So what we were talking before, just as someone said, this HTML kind of syntax. It's for message passing, so it's very secure. And just mentioning again, WaterML was being used for, I think, since 2010 or something like this. So what are the workflows for obtaining data? Depending on your location, depending on the place that you are at, you access data through these steps, registering or obtaining an API key, and afterwards you have an authentication layer, you send the request, and then depending if the request is okay or not, you're going to receive a response. So what kind of response you're going to get? This is a standard, this is best practice when you're deploying a REST API. The response is 200, means that it's okay. 201, the resource has been created, so you're posting, so you're putting data somewhere. 400 is a bad request. Probably your authentication later is bad. Probably the request that you're making was bad. 401 is unauthorized. 404, not bound, so you're probably making a request, and I've done it many times, that I'm querying USGS for getting stream flow data somewhere, and maybe I crossed the lat long or something like this, some basic error, and I'm setting a not found, right? Or internal server errors. Sometimes when you have a lot of requests being sent, APIs, or better said, the developers for those APIs, they really don't like that. So you have to be careful on the amount of requests that you make, and there are different ways that you can kind of go around things many times. So once you receive the response, you go back and see, okay, this is the response that I wanted, this is not the response that I wanted, and then you either handle errors or you parse information. So we're gonna go and explore a little bit of these APIs. It's already been an hour and 8 minutes, so I only have a few more slides. Perhaps after these slides, we can take a little break and then we come back. But I'm going to go. No, let's do something. You guys want a little break right now? I think 5 to 10 minutes will be fine. We can put in the Q&A, or maybe we can finish before the data retrieval cleaning part. You can put it in the Q&A. Break. Okay. All right, so before we go into the APIs, we're gonna have a little break of 10 minutes. So please be back here in 10 minutes, and we're going to go ahead. I'll pause the share and stop sharing. And I'll stop the recording right now.
Yeah, thanks, Carlos.
Resume recording, and I will minimize the Q&A. I saw someone ask about sharing the slides. We will share the slides afterwards, once we finish with this, so that you guys have them available first. And that's going to be done for the next also presentations. I think we can continue and get the next part. So let me share the screen. Share. Good. Okay. So right now, what we're going to do is explore some of the data sources that we were referring to. And the main ones that I want to share are some that are widely used. So I'm going to go ahead and here, USGS water services. So the USGS water services has different values and different endpoints that you can access for obtaining information. So I know that a lot of you folks are working with Streamflow, but I also saw from the cohort there's some groundwater analysis being done. There is, of course, GIS systems. There's a lot of information that can be obtained from here. And I think the USGS, the water service that they provide, have a lot of very interesting and real-time values that you can obtain from there. And we're going to be exploring afterwards, after lunch, some of these APIs. But I just wanted to show you guys how this looks. We go in here, water services. And let me put in here, learn more on groundwater and learn more on instantaneous values. Um, as I was mentioning, it's time series parameters. It is being done through XML format, JSON format. There is tab delimited as well. The service that they have, USGS, is REST friendly. That means that you can access this directly here in the URL. Might be able to do that right now, actually. And they applied the same architecture for the REST API throughout all of the different resources that they provide. So this one is for instantaneous daily values for a particular location. Same with the groundwater levels, they have the same structure. And it's very interesting because they also have this kind of tools that enable you to make calls directly over there. So instead of sending a request using the particular resource that you're trying to obtain through a URL, you can just do it in here too. And sometimes that gives you like a nice generated URL that gives you some format. And this is the example that I want to show you, but just to go ahead and show you more about the page, using a web service through Adobe Flex. I don't think many of us are using Adobe, but if you're using it, please go ahead. This is something that I don't, maybe I can cover it right now. So CORS is cross-origin resource specification, which sometimes can be problematic when creating web applications or making requests with web applications because of cross-origin, maybe intrusion or injection. So it's a security concern. Not all browsers give support to CORS, and I'm not just talking about USGS, I'm talking in general. Once you go explore the data sets that are out there and you're making a request and you're getting this error on your application, it's exactly that.
Did we start recording?
Yes, they start recording.
Okay.
So what is the format that this particular resource has? I think we can just copy it in here. So service, this part that afterwards tells you what the resource you're getting from, the format, the site status. You're not gonna have to do this afterwards. I'm gonna show it to you. Right now I'm getting an error because I didn't supply enough parameters in the URL. But that's something in specific that you need to specify in here that we're going to be doing afterwards with the Hydro. So another resource is NOAA's APIs. They also have very good information. I'm not sure if you need to, you need to authenticate. So you need to create an authentication layer for, an authentication layer for it. And they have different formats such as your JSON, WML, XML, CAP, ATOM. Features are, and they're pretty reliable. So that's a good thing about governmental forecasting processes in which you're not going to expect USGS to, well, at least you're not expecting anytime soon for USGS or NOAA to deprecate their APIs. That does happen, but I don't think that's going to happen anytime soon. So this is a nice example in here of something that I was trying to show you here with USGS. So all of this is a request already for an API, and many browser technologies already allow you to create this nice structure. So you see everything is nicely and separated. And when you make a request, you're able to understand a little bit further about how that looks like. The last one that I want to share, at least from the REST APIs or the, well, this is a post one, is Quasi's HydroShare. So HydroShare is not directly an API. They have an API resource that we can that we're going to be exploring afterwards. But I want to show you this so that you, if you're not familiar with it, if you're familiar with it, please give it a little bit more of a usage. They have tons and tons of information that is community driven. So someone created a resource, did an analysis, and afterwards they just put it somewhere in HydroShare, and you can get different outputs for some of the common things. For instance, a mud flow if you're doing some groundwater, or statistic water levels if you're using the stream flow, temperature, time series. If you're using the water management system of USESE, there's a lot of different distribution systems that are available in here, and just go ahead and explore it a little bit more. And I'm going to go into any of them. I don't really know any of this data, but I'm just going to go to one of them so that you can take a look. What that looks like is this. You have, for this particular name, you have a name and what it is. And afterwards, it tells you specifically for what location that is coming from. So this one is for just up of Salt Lake City. It tells you the content of that resource. It can be in different formats. It can be JSON, XML. It can be in Excel formats like CSVs. And if you have some resource for yourself that you want to share, that you can do it in here as well. And you can get a DOI for sharing that information. So you can get some citations if from your data source. Okay, so those are some examples, but I also wanted to share some of the more complex data sets and how you can interface with them. And I put this in here because many times the data sets that we're talking about, if I make a resource for a particular station in USGS, it's not going to be heavy. It's going to be some kilobytes, and that's not going to be a big problem, and I can manage it. But what if I have a very big 5 gigabytes, 10 gigabytes, 15 gigabytes HDF5 file that I want to interface from? And how am I getting that resource? So there are many ways of getting data across the internet for our domain. And these are some of the examples just to cover everything. The threats data service. The threats data service is from NCAR, UNICAR. And their idea is to provide resources for getting information from different protocols, including OpenDAP, OGC, again, through HTTP requests. There's a lot of information and documentation that you can take a look into. What is it that they're trying to cover? What is it that they're trying to do? Many of this provide not only information from data services for across, this is data services for across the world too. So information from reanalysis, from analysis, you can get all of this one, many of this over here. And probably what you need is somewhere around. You just have to explore it. So another one is GeoServer. So GeoServer is this open source for sharing geospatial data. And it's really interesting, and it's highly supported too. There is an OGC implementation. So you're going to be hearing about this OGC implementation everywhere, because there's a big push for standardization of geographical system data sharing and web coverages too. And there is a lot of support. You can take a look at the different sources that they have available. And I think this one, you need to download it from where I can see different versions for it. And I'm not going to go and download and show you that, but if you want to, please go ahead. Another nice resource to get this graded files from is the NASA Earth Engine. So if you have, I really love this page actually because it's so intuitive to go ahead and take a look. They have radar data, they have data from precipitation products to gridded data for hourly discretizations for many different things that you can find on. You have to, if I'm not mistaken, you have to make a request for download these data sets. Let me see if I can just download this .cdf file. Yeah, you have to log in and create a username and password, and there probably is a limit for how much data you can download from over here. I haven't downloaded that much information from here, so if anything, take a look and yeah. Okay, something from the US government data resources too. They also have DEM models, DEM information in different formats. This is in XML. These data sets, they can be filtered by different things. For instance, sediment transport. And here you can get some information for different locations too. Substrate, coastal marine, and fluvial geomorphology. So all of these data sets are over there for exploration. And in different formats too, XML, CSV, HTML, organizations that are sharing this data. And this is just some of the data sources that I just put as an example in here so you can take a look. I think there's some questions. Let me go ahead and see. Bangladesh, no internet, country today connection. Okay. Yeah, we're going to share this one. Oh, thank you for sharing neuroscience. Okay, let me copy this one and let me take a look. So that's great, actually. Thank you so much for sharing. Always good to have data from, if you have some resource that you would like to share, please do so. You can do it in here and we can, probably update in here. I'm gonna put it in here, actually, now in neon. Yeah. Oops. There you go. So that you have it available. Data samples, let's see. So yeah, just when we upload this, or if you want to just Google it, just take a look and see all the different variables and information that you can obtain from these resources. Okay, the last one is before we go ahead and get started with the actual processing part of the retrieving process. Let's see the data sets from the European Commission of medium range weather forecast. If you're doing a lot of weather forecasting, you can get really good data from over here. They have a web API, they connect through different locations. It's free and public, and there's a ton of information here that you can obtain for your particular use cases. Not only for the capstone project, of course, just go ahead and take a look at what you have in the capstone project, but also within your research, perhaps you can find some information within these resources that is of use for you. Okay, good. So I'm going to go ahead and which ones do I have? Yes. So I'm going to start right now explaining a little bit of the tools that we're going to be using, at least after lunch. So particularly a bit about Hydrolang, how you get data, how to parse the data from over there, and two particular examples that I'm going to be using are USGS and Quasi, and how to get to get information and through which kind of request you're getting that information from. And in particularly the data retrieval process, we're going to be doing some cleaning as well, but I'm leaving a lot of the cleaning processing part for tomorrow too. So USGS, right? So USGS endpoints, as we were talking, send values, daily values in groundwater. The access URL is fairly simple. And what you do is, depending on the location, depending on the service that you're trying to access, you append those arguments into URL. The URL is going to make the request, and after it's going to come back to you. But more often than not, that request is going to come as in a format that is not what you really need. And you need to understand that for a location-specific resource, you're probably going to have to do some data cleaning and sorting prior to obtaining the data itself, the information that you want to obtain. Why? It's because there's a lot of metadata, right? A lot of metadata that is being served, and it's important, of course, that you go ahead and take a look at the metadata and obtain the relevant, if it's relevant for your case, if it's relevant for your information use cases. And so I'm going to, maybe not just JS, I'm going to start with here with quasi-hydro portals, because I show you how to get into HydroShare, but I'm going to show you also the hydro portal from Quasi. And this is a very nice web service that provides data for not only USGS, but different resources across the world. And we're going to be interfacing with USGS daily values. But what I wanted to show you is that through Quasi and HydroLang, you're able to obtain data using a subset of variables that are making it easier for you to get specific information. And that specific information is accessed through these kind of resources, in which you can get site information, sites for a bounding box, sites for objects, sites for different sources, values for a site, values for a variable, information from a particular variable. And we're going to go through them in the example of the afternoon. And I guess right now would be a good starting point for perhaps, yeah, I'm going to finalize this presentation real quickly. I put some resources for some cool web applications that you can use if you have some complex data sets that you want to interface from. These folks from HDF5 group is European, I think. They put up this nice web application that allows you to get data from different, if you have an HDF5 file that you want to upload and share, you can open it through here and you can get started with that. I think there's a way to add this. Maybe there's an example page before. Let me find it in here. I wanted to share it with you guys before. I cannot find it. Maybe I'm going to share it afterwards. But yeah, this is something that allows you to visualize those HDF5 layers in a comprehensive way. And the other one is GeoTIFF. So if you have a TIFF file, you cannot render that TIFF file in the web as easy as it sounds, but you can do it through this nice website. You can, if you have a URL for your GeoTIFF, if you have, or you have it in your local storage, you can just upload it in here and you're gonna be able to see it. So that's, you get the resource, you obtain it from somewhere, and you say, okay, I don't want to just download this and see if it works for me or not. You can just, go through these different examples. And this is just a subset of examples that I'm sharing here. Something else also about APIs and public APIs is this amazing, someone put this together. It has over 300,000 or more stars in GitHub. And it's about public APIs that you can access for not only for the things that we're talking about today, hydrology, environmental sciences, but everything else. So if you want to say that you create an application, you want to connect it with different things, animals, anything in general, you can do it. Maybe have some dummy data. So take a look at this. It's good for development because you just need to have an idea of what you want to do, and then afterwards just access it through here. So again, this is going to be here in the resources. And right now, I'm going to go ahead and explain some of the tool that I was that we're referring to in the beginning, which is Hydrolang, right? So if, well, again in the beginning, where is that? Right here. So if you type hydroinformatics, Hydrolang, or something similar to this in Google, you're probably going to get it. I'm still going to copy and put it in the Q&A. I cannot put it in the Q&A, but you guys can access the chat, right? Everyone, I think you can access the chat. So I'm going to put it in the chat. There you go. So if you go into here, where you're going to get is into this page, Hydrolang training. So this is some training materials that we have developed for the Hydrolang library. I'm not going to go into it right away. I want to show you two different things. First is the GitHub page where this lives. So we have explanation of what Hydrolang is, what it does, some of the contributors that have added into the library. So what Hydrolang is this modular framework, modular JavaScript framework that is enabling the use of multiple data resources with analytical tools and visualization tools for creating both analysis on the web and web applications. So it is a library that is easily interfaced and is easily customizable and can be used as a standalone for creating a web application, or can be used, of course, paired up with other things that you can deploy. It's available as in here in GitHub. You can download it in here. Or there's also, I don't know if you are familiar with NPM, Node package system. Node is a way of getting resources from the internet. It's like they grab all this code and then put it together, similar to PIP in Python, and you can install it in your web application as well. So there's two different ways of getting along with the library. So some of the particulars that I want to show you is there is here in the documentation, no, sorry, documentation, no, in here in Hydrolang, you go into modules, data. There's an explanation of all the data sources for each of the available requests that you can make with Hydrolang. We have our own that cross-origin resource sharing that I was talking about before. We have our own protocols for overpassing that. It doesn't matter where you are. We're able to just access it. We have resources for Spain, the UK, FEMA, EPA, Italy. There's this public resource as well. There's some other ones that are not here that are in the public documentation. We have interfaces with Quasi too, which it's an easy way to get all those data from well, many of the data that I shared before with part of HydroShare and part of the WaterML project and process through Hydro. So you can go ahead and take a look and see if that that's going to be beneficial for you, your end case, for your use case. We also have the documentation. So the documentation of Hydrolang is quite comprehensive, as I mentioned before. I'm going to be talking more about the different applications or different tools that you're able to interface with it. But today we're going to be focusing on data, right? So data downloading, data uploading, retrieval, transformation, um, and parsing and understanding how this data looks like, and the different data sources. So data sources include water quality products from NOAA and USGS efforts, World Bank, the USGS, NOAA, the National Water Service too. There are some mapping interfaces that we're going to be covering in day 3 that you can integrate with them too. So from here, I want to go into the tutorial space. So the tutorial space looks like this. What I was referring to about Hydrolang is here described as well. The way you access or utilize a library is through its API. So it has a modular API that allows you to access it this way. So I don't know how many of you are familiar with HTML, JavaScript, CSS. If you're not, that's completely fine too. We can cover that in the hands-on experience too. But it's fairly simple to unload the library just as any other web library. You either put it as a script or you unload it as a you inject it as a CDN file, as a CDN library into an HTML application. If you don't want to download the library from the GitHub, you can also do that too. And afterwards, you create through the JavaScript notation an instance of the library saying new Hydrolang, and then it has 4 different modules. And I'm going to expand in here so you can take a look at the modules. The first module is data, visualize, maps, and analyze. The data module contains all the data retrieval and access to the data sources that we were referring to before. The visualize is for visualization of maps, charts. We're going to be using part of the visualization parts of Hydrolang as well as other online libraries too. The analyze contains particular functionalities from statistics for a simple hydrology, some for neural networks as well. And there are many use cases that you can do with Hydrolang because of it enables you to connect with the data resource cleanup, put it in a table in an HTML or in a map in an HTML, and you already have a nice comprehensive web application for yourself. How do you use the functionality? So all of them are all of the ways of using Hydrolang is through its functionalities, and the functionalities are accessed this way. So you have the module, the function. So you put hydro dot module dot the function, and then the different parameters, arguments, and data. I'm going to be perhaps explaining this a little bit further afterwards with the what does each of this mean. If you're unfamiliar with JavaScript, this might seem a little bit strange, but it's not a big deal, to be honest. So aside from this, we're going to be working today with Code Sandbox. So Code Sandbox is an online resource that you can use not only for this training, but for further trainings as well. So if you don't have to sign in right now, but if you feel like you would like to, it's free for you too. You can have different applications saved up over there. And it allows you to have like share your code, share your apps in a very straightforward manner. So yeah, I'm going to go into the data part. And before I go ahead and explain a little bit about this, do we have any questions? And I'm going to stop right now. No questions so far? Let me check the Discord. I think I saw something in the Discord. What we'll do is going to share the Google Drive link into the WaterSoftHack page so that everyone has the availability for accessing those. There, I'm going to work with the folks from Clemson to put that those presentations out there today, at least for the data retrieval part. What else? What else? Okay, if there's no more questions, I'm going to just go ahead and quickly show you the different agencies and different endpoints that we are talking about before we head into our break. So perhaps we can stop in the next 2 or 3 minutes. So as I mentioned before, data is one of the biggest components of HydroLang. HydroLang enables you to retrieve, clean, transform, upload, and download data. How you do it depends a lot on the resource that you're trying to access. A lot of the code available in the library is meant to grow depending on the different resources. So if you have a resource that you think that the library can benefit from, please let me know and we can share it. We have a particular subset of endpoints that each of the resource is serving. So as I mentioned, we have Quasi, we have some in-house in here from the Iowa Flood Information Systems. We have global things from the World Bank, Meteostat, NOAA. And what you do is each endpoint from each resource has a particular way of interfacing with them. So they're going to ask you, hey, you have to, whenever you send your request, you have to send it in a particular subset. We have in the library, let me go and share with you. In the library documentation, all the data sources are correctly documented. So if I go and see EPA, for instance, more information about each of the resources can be found at the top of the page. EPA, for instance, gives you precipitation data from, I think it's NLDAS products. So how do you get those precipitation data? You have to pass some parameters for that, some geometry parameters, some temporal parameters as well. And afterwards, when you're making the request, I'm going to show you how that looks like. It's sent back as a JSON object. Similarly, if I were to show you one from the National Weather Service, for instance, this one is grid points. So where do you have access for forecasting data resolutions of in a region across the US? You do it through this green points endpoint. So overall, I just say, please go ahead, take a look at the documentation of each of the resources. If there's any resource that you feel like it's of your interest. In the afternoon, we're going to explore USGS, Quasi, and some other resources too for the transformation part. But if you want to see a little bit more about it, please just go into the tutorial and just play around and fool around with it. I think we can stop right now. Let me just go into the Q&A and see if there's anything that's being said. Reliability. Yeah, that part of reliability is what I was that's, I guess, what we were covering before in the morning. I cannot really vouch if the reliability of the information from a particular resource is great. I just know that I would probably have more confidence in the data that is being shared in one of these public spaces, because many times it's curated, and by public space I mean NOAA, USGS, National Weather Service. You know, it's they go through a lot of processing before putting that data out there. So, okay, guys, any more questions before we go into the break? I think so. Anyone from the panel, if you have any questions, something to share?
Right, sounds good. Thank you.
Okay, perfect. So let's
Good.
get back here in about, I'm gonna stop my sharing right now. Let's get back here in an hour then. And I'll see you soon. Again. Okay, it says, so if I want to download data from sources that are different than a listed hydroline, can we do it? Yes, of course. If you have some data sources that you're interested in, that you'd like to bring together in your capstone, or you know, use it throughout the development of the project, or that you have questions for or on, of course you can use it. That's not a problem. There is so perhaps afterwards, when we are moving forward with the project and the content of the course, we can cover how much of the tools that we're showcasing can and should be used. But definitely, if you have some data that you're interested in and you cannot find it within the data source of Hydroline, first of all, let us know. Maybe it'd be interesting that we can integrate it over there. Or you can just, you know, use what you feel it's is the best for you. So yes, I answered live. Okay. Okay, I'm going to share my screen now. Thank you so much for everyone who replied. I'm just gonna read the replies real quick while I am sharing my screen. There you go. So we're gonna go in here into the data, but very interesting what folks are working on with the data part. So again, precipitation, stream flow, sediment data, stream flow for model calibrations, data sets from USGS, NOAA, and larger data sets. So that'd be interesting to explore too. Let's see what we can do for you. Nutrient concentrations, high frequency turbidity. Okay, so some water quality. Package is NAR. Okay. Be nice if I can use some faster ways to get it out. Okay, perfect. Let's see what we can achieve for all your needs. Thank you so much for replying. So what we're trying to do is, you know, see where you are at and try to meet you there, or at least get you as close as we can. Yeah. And as for the question that was raised before, we are showing the tools, letting you know all the things that are available to your disposal that are open source, but definitely not the only ones that are out there. So if there's anything that you feel you can use to an extent, please do so. Always know. So I'll continue moving forward toward the hands-on experience. So I'm just gonna reshare again the tutorial for Hydrolang in here, so that everyone can have it, and we can continue with how this would go. We were talking before the break about how the Hydrolang is on itself. It's powerful because of the tools of retrieving, cleaning, transforming, uploading, and downloading data from different data sources from different locations. We support REST APIs throughout different domains and different parts of the world. The main idea is to have providers that enable you to get that data. and serve it to you in a particular format, serve it to you in the format that you will need it. And of course, since it's a web application, we're focusing also on web applications, but that's not the only kind of format that we can get it from. You can learn some ways of interfacing with the information, with the data, in such a way that it's usable for your particular use case or your particular need. And we're also working continuously to adding more information and more data sources that are not just RESTful APIs, but other API connections that are open source and freely available for usage. So talking about the first exercises that I wanted to share, let me just go ahead and explain to you how the library works. And I will do so by, I think I show you this space first, the code sandbox. So this web page is just a simple web page. It has a bunch of different locations. We put it like a containerized environment that is running on the browser. So all the processes that I'm running within a web browser are done by both HTML. HTML is a location where everything's at, and the JavaScript. JavaScript is the language that performs all the computations and calculations required. But also it's powerful because it has native integration with making requests through the internet, right? So the requests are HTTP, HTTPS, and different kind of protocols that you use for getting that information. Now, what Hydrolang does is instead of having to create a big bulk of code that you need to, so you can query something in like in space of USGS, and you have to append some different things, headers and other spaces there, so you can make the request efficiently from your web browser. We deal with it in the background, and you just make your request. So what I'm going to show you here is if you click on this button, it opens a code sandbox. I'm going to put this up in here. So these sandbox environments, as I mentioned before, are running all on the browser. They have their own technology on the side. And what we're doing is, if you're not familiar with JavaScript, I'm going to explain a little bit of what's happening here. If you're familiar with JavaScript, I'm sure that you're going to feel, you know, this is very easy, this is formal, but just so that we're all in the same level of understanding, JavaScript is interpreted by the web application. The web application is just looking into what the HTML has, and that's what's being rendered, right? So just to explain to you this interface that I'm having in here, again, is this code sandbox. This is not the only one. I'm sure that when you guys go and look into, hey, how do I do this particular task online, or with even ChatGPT now, it's referring you to some other code sandboxes or some other environments that you can run this. We're using this one and another one that's going to be shown tomorrow, so that you have you know, a list of tools that you can render and create for your own. So you can fork, and if you fork, you can create an account in here. And if I'm not mistaken, you can also download some files. Yeah, export all files as a zip. So if I go here, export, and afterwards, this is just exported right here, and I can just get it. Oh, and by the way, we're gonna be put the presentation that we showed today in the morning up in the WaterSoftHack website. So how does Hydrolang renders through the HTML, and what you do is HTML is basically just a container where you upload or you load scripts, and you load the scripts through the definition of this script header. So the only thing that this web page is doing is enabling me the use of the Hydrolang instance, so I can make an API call. Now, what is the API call that I'm doing? I'm going to go into a folder, which is here, source, and then main.js. I think this one has nothing. Yeah, has nothing. Delete. and it's main.js. And in here, what we're doing is, did I not have to delete that? I think I didn't have to delete that. I'm sorry. Let me see, refresh. Okay, so what we're doing in the main.js is we're loading Hydrolang from a code repository called Node Package System. Yeah, just as I was explaining before, if you're familiar with Python, if you're familiar with R, if you're familiar with these big libraries, JavaScript also has its own packaging system. You can find thousands and thousands of tools out there. So you create powerful web applications, render things in 3D and whatnot. We have Hydrolang hosted in one of these ones. And it's in multiple versions. The latest version that is available is 1.1.10. So in 1.1.10, you can even render flood maps, mitigation, and estimations on your screen with, I think, 10 lines of code or something similar to this, completely customizable. But what I'm showing in here is how is the library being rendered? So first thing is in the HTML, I declare the script, and I'm making a call outside to this page called cdn.deliver.net.npm, and it's asking for this particular version of Hydrolang, but there's multiple versions that are hosted over there. If you go into this page and just go to Hydrolang, you see, this is how it looks. It's basically all of the code for the library in a single script. So that is all we're going to find, but you can search for Hydrolang npm and you find it here. So his releases that he has, the same documentation as in the GitHub. You can find more information about it and all the releases, with all the releases being documented as well. So once I make the call for the library, and I know that if you're not familiar with JavaScript, this might seem a little bit strange, but I'm going to try to explain it to the best possible. We are going to be interfacing. So the main purpose right now is to interface with both quasi data sources and USGS. So what's neat about quasi is that you can access many different data sources through them. So let me go, and I'm going to go into the documentation. Again, please take a look into the documentation of the library so that you can see what are the data sources that are available over there. There are many different libraries that you can access. Many different data sources that you can access. And if you need to, in particular, access something, there is enough documentation in here so you can take a look. But Quasi enables you to make requests through different endpoints, and these endpoints include national labs, include private data sets, well, not private data sets, but data sets that have been generated by other researchers. For instance, USGS in here, there's this Andrew Forrest streamflow forecasting, some data sources in Brazil, some data sources in aquatic habitats, crowd hydrology. There is many different versions of those data sources available. And so what we're doing in here is the combination of two things. The first one is, in order to, I'm interested in is in getting the data that is within a bounding box with using Quasi. So using Quasi's water one flow data source, I send also a request called get sites by box object. So what basically this does is I define east, west, north, and south and I say, hey, Quasi, for the USDS daily values, can you please get me all the sites by box object? So get me a square box where you have stream flow values. Why stream flow values? Because the data source for USDS daily values is exactly for that, for daily stream flow values. Now, there is something to say about this notation that I'm declaring in here, and this is called JavaScript. We mentioned this before, JavaScript object notation. If we can talk a little bit more about what JavaScript is, it is a prototyped language. It is everything is an object. So an object means I can just open the curly braces, and within there, I can write anything that I want as a description. So in order to interface with HydroLang, you need to have three parameters passed into the functionalities. So the first functionality is params, arcs, and data. And that can be done in two different ways. In here, I'm showing one way if you can do it, in which you can do it. Params is the most upper layer information required for a function. So if I go back into the presentations in here, I'm saying, hey, the parameters that I want to access for the data source for the retrieval function, so this one, hydro.data.retrieve, is please go into water1 flow and ask this sites by box object. Yeah. The arcs is once I narrow down what is the particular resource that I'm trying to access, give me the required arguments that I need to send to the API so that I get the specific result. That is what arguments is. So arcs is another object, and I'm just saying, hey, anything that is an additional parameter, or sorry, an additional argument that goes for that particular resource goes in here. So the USDS daily values for this particular data type requires for me to pass the bounding box. So that's exactly what we do, a bounding box. And then I define this as an argument in here. I define as an object in here. I define that as an object in here, and afterwards I just make the call. Yeah, and the call is done by saying I'm going to declare a variable. So there are three different ways of declaring a variable in JavaScript: is var, let, and const. Don't worry about it right now. I'm just using let. And I just name it available stations and say hydro.data.retrieve. And within the curly braces, I pass the name of the variables that I defined before, params and arcs. So of course, you can do the same by just grabbing this information and just passing it in here. But I'm just doing it this way so that it's a little bit clearer for everyone. Now, something that is not as intuitive as you think is codes like Python and R. Well, all of them are scripting language, including JavaScript too. But they're synchronous. So that means that I can attach a request, and I'm sure that once I click run, it's going to run. JavaScript, since the nature of the language is that you're able to connect with data sources, with APIs, that makes this an asynchronous. And asynchronous just means, hey, I need to wait. I need to wait for the data to come to me so I can proceed and do other stuff. And there are different versions of the language. Before, they use something that sounds very scary called a promise. But now they made it a little bit simpler so that if you attach this keyword called await, what's going to happen is once I submit this request, then I am going to wait for the data to come to me, and then I'm going to have it available. Yeah, and that's exactly what happened in here. If I, let's see, I think I can do it in here. I don't know how many of you might be familiar with the web browser console or inspecting the console of a web browser, if you right-click in a space and you call inspect, and I'm going to put this down. Give me a sec. All of what you have in your web browser can be observed in here, right? So don't mind this. This is just some errors that might not be your console, okay? But what I want to show is the following. This is being rendered in the browser. This is being rendered in the browser. So when I click refresh, it's making a request. And afterwards, what just happened is if I go to sources, sorry, if I go to network, and in a network, I'm going to find somewhere down below a scripting request that was sent by my Hydrolang toolkit. And how does that look like? Oh, there you go, Quasi. So what does that look like? I append the URL and the specific resource that is defined in Hydrolang. And then I submit this payload, and the payload is just basically a SOAP, that SOAP request, that SOAP data interface that we were mentioning before in the morning is submitted in here. So we make some data mangling so that we append the correct attributes over there. And then we wait for the response, and the response looks like this. So it's an XML of all those values. But afterwards, those values are converted by Hydrolang into a JSON object. Because seeing this on screen probably isn't the best way of doing it. So we have a function over there in Hydrolang that allows us to interpret JSON objects in an easier manner. And this is what we're seeing in here. Probably I can showcase in here instead. So once the request has been submitted, and once this is done, so again, step 1 is defining this, step 2 is making the request, step 3 is waiting for the request, and step 4 is, we're going to be covering this in the third day, but is the visualization option, right? So Hydrolang also has a visualization library itself that allows you to draw charts of different kind, tables, and also JSON objects. So you can quickly interface with the information that you received. So the request is, all the functions in Hydrolang have the same argument, parameters, argument, and data. And so the way you pass the arguments is described in the documentation of the library. And here I'm saying, hey, I want to see a JSON object. And the data that I want to see is this available station that I just received from USGS, from Quasi through USGS. And so this is exactly what you can see in here. You get a response object, and the response object contains all this metadata that I'm saying, hey, well, at this date, there's no parameters in here, but I have all these sites for this particular location. So why is this information? This is in particular, this is in Salt Lake City. What I'm getting is all the USGS stations that are in the Great Salt Lake City area with a particular site code. And the reason why I wanted to get this is because I might be interested in mapping all of this putting this in a map, right? So what am I getting? I'm getting the different variables that are obtained over there. So if you explore in the metadata a little bit more, you're gonna be able to see, okay, this is surface water hydrology. This is a field observation. The data type that I'm getting is the mean. What are the units? And you can just explore a little bit more and further on. You can even see, someone was mentioning before, I remember, about quality control. So you can see what the quality control was, and then you have to refer back into the resource that you're utilizing for getting this data to see what these numbers mean, correct? And so that is the data retrieval process from start of the definition of the parameters required to make a request, the arguments required to make a request, afterwards put them in a request option. This, we wait for this resource to come back, and then we draw it as a JSON object. Yeah. So now that we have all of this here, I'm going to show, this is very nice and everything, but what if I want a particular location that I'm interested in? So I expand my object and I see, okay, I want to see one of the variables, one of the locations that I'm interested in. So I got a bunch of locations. I want to see one of them at least and see what that variable is. So we can do that by making a separate code. Yes, Tefera. Let me let you, Tefera. I think I can let you guys now talk. Yes. Oh, Q&A, okay. Oh, but there's another question. Okay, can we submit? Okay. It says, given the parameters line code, how can we inspect the data type to which one to pick? Well, let's say that one is interested in another station. Well, that's something that if you're using a particular resource, then what I would recommend is I'm going to go and see how I can download the data using, first of all, the resource itself, and then afterwards using HydroLand. You see, so I am using right now for these stations. Let's see this. I'm using right now for the stations the I'm not really sure what I'm going to get. I just want to explore if there is any USGS values there, right? If there's any streamflow values over there, or it doesn't have to be streamflow value, just if there's a station there. But then if I want to see what those are, maybe a little bit more of data manipulation can be done so that I make a request for each of the stations, and then for each of the stations, I can append that into a map and then just see that. And there's an example, if you go, I don't want to go into that too deeply. If you go into the data visualization deck option, there is an example of how to do that. You get all the variables, all the stations in here, and then you map them. And for each of the stations, you get all the requested information available from them. I don't know if that answered your question, Ayo Bali. Good. Okay, so taking a step back, I'm going to show you now how I know a particular station that I'm interested in, and it's the very first one, right? The very first one that I have, which is, I expand this one, site info, and it's this guy right here. Why do I know this? Is because I know that USGS, so you need to know what the API requires for you to get data from them so that you're able to request the data, correct? So I know that USGS, what it needs is the following. It needs the site ID, so the site code, and I just define it here as site, the start date, and the end date. Format options, it can be in CSV, it can be tabular. I am requesting a JSON object. And since this is a USGS station, in here I'm not calling directly USGS, I'm using Quasi to call USGS. So some of the functionalities of Quasi, I'm using them to call USGS. But in here, I want to actually get the data for that particular station. So what I do is I use another resource to make a query. So again, we're using Quasi in USGS. I was using USGS through Quasi. Right now, I'm using USGS directly. And I just declare it in here. The list of resources, the list of the data sources available through HydroLand are found in here. So that way you make a poll for those stations. And you can even, if you go into the documentation of the library, you can go in here, click on it, and then it tells you more about what that looks like, right? So this one is the HTML, the service of instant values. What does it require? For instance, if I want instant values, I need the format side, state, city, the Hawk ID, if I know it, the county code, and so on. And there are different versions of there in the library. So since I know that is a USGS station, and I know that is daily values, so USGS, that's the first endpoint. Daily values is right here. So I just need to know the name of the resource, daily values, and I put it in here in data type. Here I'm attaching this transform equals true because for several of these external resources, you already kind of know the structure of how they're going to send back the data. So since I'm requesting a JSON object and I kind of want to visualize it right away, I don't want to just go into it and parse it and visualize it. And then visualize it. There are some functionalities within HydroLang for some of the APIs, not for all of them, but for some of the APIs, particularly NOAA and NWS, USGS, for you to pass this transform true, so that you don't get the raw data, you get the transform object. I'm going to show an example afterwards with Python and how you do that exactly the same thing, so that maybe it's more understandable what's happening. So I do exactly the same. I declare the query. The name of the variable, it doesn't really matter. You can be named whatever. The only thing that I need is the structure, and this structure is particular for each of the stations, for each of the endpoints and APIs, right? So then I go ahead and made the same hydrolang.data.retrieve, and the first params is this USGS query. So I put params to the object and args to this object in here. I await for the response. And then afterwards, I want to use not the JSON visualizer because I already transformed the data. So I guess there's something to say about the different data types in JavaScript. Basically, there are two objects. Objects are like this, and arrays of numbers, arrays of different versions. Yeah. And afterwards, I want to download the data if I would want to. So once I get the retrieval back, the USGS data, I call the data module draw module to visualize a chart, a time series chart of the USGS data. And this is exactly what I'm showing in here. And the good thing about the web is this is powered by Google Charts API, by the way. So the good thing about the web is, it's very interactive. So I can zoom in and just get for a particular station something that I might be interested in through using my my left click in the mouse, or if I want to go back, I just go left click. If I want to download this data, then what I would do is I just call hydrolang.data.download, and I pass the type CSV JSON. I think there's tabular as well there, and then just pass the USGS data. I think there's some questions. Let me go into the Q&A. It says, yes, there are different ways to get it. And if I'm not mistaken, USGS has, maybe in version 10, maybe it's not updating here. There are different variables over there included. Mohammed. Kalina. Is there a cheat sheet somewhere to which parameters we need to provide for each database and works like agents to request action? Yeah, so I guess the cheat sheet would be the here, this part for each of the resources. You have what is it that it's needed, So what we have added in here is, okay, for instant values, what do I need? And the format, site, state CD, hog, county, and so on and so forth. But there are many different endpoints, and some of the endpoints do require some particular things. So what I would say is you can go into the site and see what they're requiring. We can perhaps create something easier for you guys for now, like for the most common ones, what you might require to talk. Yeah. Okay, good. Okay, any other questions so far? Okay, answer line, done, answer line, done, done, okay. Okay, so how are we doing so far, by the way? I know that that was perhaps a little bit, or maybe a lot, and I know that we are covering like a broad range of things so far, but this is like the startup of the whole data acquisition, data processing part, and afterwards we can go into deeper. There's something in the chat. Explain a bit more. Okay. Cielo, I'm going to allow you to talk. Perhaps you can. Sorry. What part were you? No. You can put it in the chat. What part is it a little bit more confusing for you? In the meantime, while you're right, there's another question here. In this case, you demonstrate only for one station. Can you explain how we declare station code? Whenever we want all the station in a bounding box to display in a chart and down. Oh, perfect. Yes, that's a great question. The other one, how do you go in code sandbox from a hydro line? Do you copy or click? Okay, perfect. So I'll go for the easiest question right now. And how do I go from the hydro line? So I'm going to close this too. So you can download the code or just keep it. In here, in this space, you click in here. There's a little button that says Open Code Sandbox. And when you click that one, it should open this whole space. And you should see this this part. And I guess I can explain a little bit more about how do I do this chart. There was another question. But thanks, perfect, thank you. Can you explain a bit more? So I just tested out my own and see what partners here. No, perfect. I think that's a great question, and it kind of ties up with what Cielo was saying and the last question in the Q&A. I think I can show you right now how that variable definition would look like if you want to scale up into a project, right? So yeah, let's go ahead. I'm going to skip some steps. Then maybe we can go back to them afterwards if we need more detail. But it's going to be a little bit clear on why is it that we did this. This is for one particular station, right? For one station, I got this site, and then I got to make the request of this is from 2000 to 2023, the first days of the year. What if for all the stations that I have in a bounding box, I want to download all the stream flow or any other variable that is out there? So I'm going to go and take it further into this data visualization deck case study. And if you guys want, it'd be good for you to take a look. There is some mock-up not mockup, but some HTML to append things in a location, because when you draw a chart in HTML, you draw a chart in a web page, you need a location to append that to. So you make these declarations. I can talk about this a little bit further in the visualization part. But what I wanted to show is through all of this logic, I grab exactly the same information that we showed before. Water one flow, you make a request, I get all this information. But instead of just plotting for one single station, I grab the site code ID. Right, and that's part of the capstone project. That's part of your analysis, that what you have to do afterwards. I grab the site code ID, and I know that I can use that to make a request into the USGS stations, so I get all the data from USGS for all the requests that I have available. And then the only thing that I need to do then is to visualize it and put it in a nice table or in a little nice pop-up or something similar to this, which is, it looks much more dramatic than what it is. It's just appending things in, like, content into a space. But the way it looks like is like this, right? And I'm going to open it in Sandbox. Again, just clicking here, open Sandbox. This one looks a little bit different because it's a little bit more of a complicated example. So in here, we brought together everything, right? It's fully functional as well. And again, this is for Salt Lake City, so maybe it'd be good if you just move around some stuff and some of the requests that we're making to Quasi for USGS. And I'm going to show you here the main example, because what I want to focus on is on the request part. So retrieve data, I retrieve all the sources from USGS, yes, for these locations. And then this data, I get it back. This is some function declaration in JavaScript. If there is some confusion about that, we can cover that too. I know that, again, there's not everyone knows how to work with JavaScript or whatnot, so it's completely fine. But the logic itself is there, and you don't have to use all the styling and everything in there. That's completely fine. Now, once I get this data, what I want to do is I'm going to get it as a JSON object, right? And what I want to get from the JSON object is the site code ID. So this is exactly what I do in here. I transform the data so that what I want to obtain is, I know there is a namespace in the object called site. And I know that the object that I'm going to parse is a JSON object. So the function hydra.data.transform allows me to grab all of this information that I'm getting in here. And then the only thing that this is doing is, since I know, just as Python, right, since this is a function, I'm just passing this function into this other function. So I'm just waiting for the request to finish so I can start doing this task. And then I already know this example, of course, so I know that there is some information that I would like to see. For instance, the site name, the geographic location, code, the variable definition that I'm getting from each of them. And once that's done, this is just data, getting information from the data source itself. I don't want to make this bigger than what it is. Believe me, it's not. Once that's done, then I make a USGS request. So I cannot request for each of the sites each time I refresh this page. So instead, what I do is I click on a station, and all of this information that is shown in here, all of this, is just being obtained from the request that we made through Quasi. the name of the station, the latitude and longitude. So I use, of course, this to put it in the map, and the variable that it's available over there. So if I go ahead and I click on retrieve data, then this button is going to make the request through USGS. And if the data exists, it's going to pop up. But if it doesn't exist, it says like this. So we can try another resource, for instance, this one, Weber River, retrieve data. And then once the data is retrieved, which is hydro.data retrieve, I wait for this data. Again, the same stuff that I showed in example 1. I want to draw it, and I want to draw a chart. And what data am I going to draw? The USGS data, right? But I also want to draw some statistics on this information because I kind of want to know before I download the data, before is it worth it? Is it actually reliable? I kind of want to know a little bit of statistics about the information that I'm obtaining. Yeah. So there are some functions in HydroLang for doing particularly that, some basic statistics, which we're going to be covering tomorrow and perhaps a little bit on Thursday as well. Hydro.analyze.stats, basic stats. And I retrieve the data, and this is being live retrieved, right? USGS data, and afterwards I just pass it in here. And has the same structure, parameters, arguments, data. I don't have any parameters because the only thing that I need for a basic stats function is the data itself. So I don't need to pass anything. And what I'm getting in here are those values, number of values, minimum, maximum, sum, median, and all this information. And of course, a quick visualization that is also interactive. If I want to download the data, I just append that function, that functionality into the a button again, download data. And let's see if that request was done. Maybe it wasn't done. Anyway, that is the data request processing. That is the main part. You click on a button. You cannot make a request for all the stations. So you kind of segment it so that when you make a request, you retrieve the data per station and so much for all the stations. But you can render all the stations in a map. So you have a clearer view of what that looks like. Troubleshooting. Let's see. Sandbox copy option from HydroLang. Do you mean that you cannot open? So if you click on this one, or maybe you click on this one, this preview. Maybe you click on the preview. Oh, well, something else that you can do is once you open the sandbox and close it again, you can fork it. So yeah, you can download the data. And by the way, I think you're not getting the preview, yes. So if that's the case, maybe you can fork it. And by fork, it's just going to make a copy in this sign-in, sign-on optionality for option for the code sandbox environment, and then afterwards you're going to have a exactly same copy within your account. So try doing that, and if that doesn't work, then you can download all this as the file. And if you guys want, I think it'd be good if we, if you can get VS Code tomorrow or any other coding environment. I do recommend VS Code because it has a live server option so that you're able to interface the a server in a web page, so you can edit your web page. And probably for your capstone, you're going to be doing a lot of local development and then perhaps putting in the hosting environment like this one. So maybe we can do a brief tomorrow in the morning about VS Code and how do you declare this stuff. I only have 5 more minutes, so I wanted to show you the last part, which is, okay, that's all nice, Hydrolang works, and you can create these web applications, but what if I want to take a step back and just download the data for a particular station using Python? And I created this very simple mockup. Connect. And I'm using, you know, if you're familiar with Python, probably you already know about Google Colab. It's free. If you have a Google account, you don't even need to. We're going to do in Python as well. I'm going to show you how to do it in Python. The main idea is that you can directly use it with the JavaScript version, but I'm going to show you how to do it in Python as well, so that, you know, we kind of cover everything. And what I wanted to show you is, you know, you use request library, very similar to Hydrolang if you were, you know, basic get usage too, basic post, then pandas for mangling, then matplotlib. So instead of Google Charts, they use matplotlib, and it's the same stuff. You submit the request. This is the URL. And what we're doing in Hydrolang is in that one line of code, we put all of this together. So we make the request, we convert it into JSON, then we transform the data, and then to visualize this information, you use a data frame, right? A pandas data frame, and then you plot it. And this is customizable if you know Python. It's pretty straightforward to do the customization, and then you get exactly the same resource. So what I want to show you is, you know, with the JavaScript, you can do exactly the same, even a little bit straightforward because of the whole data request part. But what you feel comfortable with, please go ahead and just. So I have 5 minutes. I think I can stop right now. Just questions and answers that you guys might have. Tomorrow is data analytics. Sorry, yeah, data analytics. So we're gonna be covering much more on the transformation, mangling, sorting, that kind of stuff. Go ahead and take a look at the resources for Hydrolang and see if there's anything in particular that's confusing. Please, you can shoot me an email. I'm gonna share my email in here, or you can shoot it to, you can send it to WaterSoftHack2. But it says, how can we get access to this Python code as well? I guess we can share it. I can share it afterwards. Sure. In the collab. Any other questions? Oh, please, if you can, go ahead and start talking about the project ideas that you might have for the next week. So we haven't covered anything about geographic data sets or anything similar. We'll try to cover that tomorrow. But okay, thank you. Okay, guys, so I'm going to stop sharing now my screen. I think we have 3 minutes. Thank you so much for attending the webinar. I know that it was probably a lot to dig in, and questions, please let us know. We're here to help. If you have a particular data set that you're interested in utilizing, please let us know. We're trying to make it work for you. And yeah, that's all from my end.
Thank you, Carlos.
Carlos, thank you very much.
All right, guys. Well, thank you. Have a great afternoon. See you tomorrow.
Yeah, thank you.
Bye-bye.